So in the previous lectures we have seen what are the what are the main applications of nanotechnology and what are the uses of nanotechnology and how they have been used for how their model consensus model and what is that DSR DC model and all. So we have seen how they are correlated with US and Canada, and right. And today's lecture we will see how the fabrication of patterned magnetic storage devices are fabricated, how the magnetic storage devices are fabricated, right? So this patterning depends upon the two types of patterning, right? One is a lithography patterning and other is lithography patterning and other is other type of patterning like commercially available nanostructure and all, right? So this is what the fabrication of patterned magnetic storage device, right? So how the patterning takes place, nano pattern or micro pattern, whatever that is, or the fabrication of magnetic storage devices takes place, right? So the main outline of this particular fabrication of magnetic storage devices consists of the introduction part and available techniques and comparison and description of deep pen lithography and description of nano imprint lithography and what are the summary and references. So these are the main outlines of this particular fabrication of magnetic storage devices, right? Magnetic storage devices. So if you come to the introductory part, the problem is superparamagnetic effect limits size of bit domain. Superparamagnetic limits in the sense the domain size. See, superparamagnetic nature in the sense the domain will be single domain, right? So single domain particles. So superparamagnetic effect limits size of bit domain, and solution is spatially separate bit domain. Aim to produce patterned memory storage device. The aim is to produce a patterned memory storage device. And the current status is the production time around 10 seconds per disk, and the production cost is $1 per gigabyte, right? So this is what the introduction regarding the storage devices, so magnetic storage devices. The problem is the superparamagnetic effect limits size of bit domain, in the sense single domain size. It is single domain size, right? Single domains. So single domain represents the superparamagnetic state, and the solution is spatially separate bit domain. And aim to produce patterned memory storage devices. And the current status is production time is around approximately 10 seconds per disk, and production cost is $1 per gigabyte. So the method of patterning, there are different methods of patterning. One is interference patterning, as we have seen. Interference patterning, interference lithography, extreme ultraviolet lithography, X-ray lithography, E-beam lithography, focus ion beam lithography, deep pen lithography, and nanosphere lithography. So these are the different types of patterning of a nanostructure, on any silicon chip. Suppose if you take a silicon chip of this particular dimension, right, the patterning of the particular geometry on the film requires some writing part. So that writing part can be done only by E-beam lithography, or by whatever the lithography techniques we are having, the interference lithography, extreme ultraviolet lithography, X-ray lithography, E-beam lithography, focus ion beam lithography, and deep pen lithography, and nanosphere lithography. So these are the different methods of patterning the image on any substrate like silicon or any plastic or whatever the material is, right? So if the self-assembly is block copolymer lithography, and we can use some mask also. So if you want to frame on if you have a substrate, and if you put some mask on that particular substrate, that is what replica modeling we tell. So that can be done by nano imprint lithography, micro contact printing technique, and direct film printing, where we can use electron beam projection lithography, focused ion beam projection lithography, nanoparticle pattern media, that is carbon nanotubes, iron platinum nanoparticles. So these are the nanoparticle pattern media: carbon nanotube, iron platinum nanoparticles, electron beam projection lithography, focused ion beam projection lithography, and block copolymer lithography. So what are the characteristics and definitions? So the feature size is minimum size of the MESA produced, and spacing is distance between two MESA. So throughput in number of features produced per second. Energy is the energy of beam required per unit area. So these are what some of the characteristic definitions. Feature size, minimum size of the mesa produced, distance between mesa. Throughput, number of features produced per second, energy of the beam required. So that is per unit area. Right. So the interference lithography, when we speak about the interference lithography, we have on substrate, and substrate is being coated by some photoresist material, and by using laser beam split on particular photoresist, and we can see the conducting measurement. So that's what the characteristic. The feature size is around 75 nanometers. Energy required is 4.4 joules per centimeter square, and throughput is 10 power 10 features per second, and equipment cost is around $10 million. Right, the interference lithography is very costly when compared to E-beam lithography and all, right? So here the feature size is around 75 nanometers. Energy required is 4 joules per centimeter square, and we have throughput around 10 power 10 features per second, and we have around the equipment cost around 10 power and $10 million. So if you see the advantage, what are the advantages of this particular lithography is, we have the simple procedure, we have the low energy. And what are the disadvantages? Feature size limited to 75 nanometers. See, feature size limited to 75 nanometers. That is what the disadvantage, and this is the advantage, right? So this was taken from one of the paper of lithography, where we have the substrate, and substrate is being focused on photoresist, and the laser split beam is incident on that, right? And we can see the patterning in this patterning. So developed fringe pattern in resist, and RIE rich etching of resist to fully transfer pattern. So this is what the patterning by using interference lithography. So when we use ultraviolet lithography, extreme UV lithography, we have the characteristic size. The feature size is around 30 nanometer. Energy size is 40 joules per centimeter square, and the equipment costs $50 million. Throughput is 10 power 11 features per second. So disadvantage of using this extreme lithography is high equipment cost. The equipment cost is $50 million. $50 million means very high cost, right? And energy intensive process. A lot of energy takes place, and vacuum conditions are required. That means we need to maintain some vacuum condition, low vacuum, high vacuum conditions are to be maintained to use this particular calculation tool, right? So to use this particular patterning tool, that is what UV lithography. So this is what the interference pattern. In interference pattern, we have the equipment cost is $10 million. Here we have $50 million. So when we come to the X-ray lithography, this is what you can see the X-ray lithography is. So the characteristic feature is around 80 nanometer. So advantages of this particular X-ray lithography is high resolution, large area patterning, and the disadvantage is synchrotron facility required to pattern large area. And it requires a high power requirement, thick marks required. Masking on that particular substrate, masking on the substrate requires thick mark, and the complex mask fabrication. These are the advantages. These are the disadvantages of using this type of lithography. High resolution, we can obtain the high resolution, and the characteristic size limited to 80 nanometer, right? So this is one of the basic disadvantage of X-ray lithography. Yeah, when we come to the E-beam lithography, the characteristic size is around 75 nanometers, and energy required is 16 joules per centimeter square, and equipment cost $1 million, and throughput is 10 power 4 features per second. So what are the advantages? The advantages of using E-beam lithography is direct patterning of substrate. Direct patterning, we can write whatever the pattern. Suppose if I want to write a pattern of elliptical pattern, or if I want to write a circular pattern, or if I want to write a square pattern, or if I want to write a rectangular pattern on a particular substrate. Let us take that substrate as silicon, right? Silicon chip. If you want to write a circular pattern on this particular silicon chip, right, people generally go for E-beam lithography. What type of lithography? E-beam lithography, because it is a direct patterning. Patterning can be written on the substrate. And it has high resolution, and high aspect ratio features. And the disadvantage is slow process. Slow process in the sense, it takes around 2 days or it takes around 24 hours to write a pattern. If I want to write a pattern of nano elliptical pattern of around 225 nanometers, right, on a silicon wafer, it takes around 24 to 48 hours to write it. So that much long time procedure is what one of the disadvantage of using this particular e-beam lithography. Right, so patterning, writing on that particular device is more complicated, right? And the other is the scattering of electrons. Scattering of electrons is also one of the disadvantage. Right, here we have the high power supply, right? We have some high power supply, and we have, this is what the chamber and all we can see here, right? So this is what the stage is we can see in e-beam lithography. So other one is a focused ion beam. So focused ion beam, the characteristics or feature size is around 50 nanometers. Energy required is 22 joules per centimeter square. Equipment cost is around $1 million. Throughput is 10 power 1 to 2 features per second. Advantages is lead scattering of ion, direct substrate fabrication, and the disadvantage is slow process, change in surface property. So these are some of the advantages and disadvantages of using focused ion beam. So the characteristics are featuring size around 50 nanometers, energy required is 22 joules per centimeter square. Equipment cost around $1 million, right? $1 million. And throughput is around 10 to the power 1 to features per second. Advantages is less scattering of ion, direct substrate fabrication, and the disadvantage is this is a slow process, change in surface properties. And another important patterning of the device is a dip pen lithography. So it has the characteristics feature size around 10 nanometer. Equipment cost is around $2 million, 0.2 million, and write speed is around 0.2 millimeter per second. The advantage is it is high resolution possible. High resolution of the patterning can be possible using dip pen lithography, and of course the disadvantage is it is very slow process as like e-beam lithography. And we have one more writing characteristic property that is called the nanosphere lithography. The characteristics features around 200 nanometers. Feature size is around 200 nanometers, and equipment cost around $5.6 million. $5.6 million, right? And the advantage is provide control of interparticle spacing. We can find about the interatomic spacing between the particles, right? We can find the control of the provide control of particle spacing, Coulomb spacing, interparticle spacing. That is what we see. Interparticle spacing is what we call interatomic distances versus potential. So we can find the Coulomb potential, right? So provide control of interparticle spacing, and the disadvantage is irregular geometry of meso scale conventions, right? So that is what the disadvantage, right? So if you come to the projection level, lithography, we have the characteristics. We have some characteristics like e-beam. So e-beam characteristics around the feature size around 50 nanometers, right? And equipment cost is around 10 million. Focused ion beams feature size around 75 nanometers. The equipment cost is around 10 million, right? And throughput is 10 power 10 features per second. And the advantage is large scale patterning used for transistor manufacturing. And disadvantage is e-beam suffers from scattering. And this is what the laser. So laser is illuminated on illuminator, photomask, and the projection lens with a wave number, right? So that is what the characteristic e-beam lithography. Feature size 50 nanometer, equipment cost $10 million, focused ion beam. Feature size around 75 nanometers, and equipment cost is around 10 million, and throughput is 10 features per second. And the advantage is large scale patterning and used for transistor manufacturing, and the disadvantage is e-beam suffers from scattering. So laser light is allowed to illuminate on the illuminator and allowed to fall on a photomask, objective fluorescent lens, and scattering of the beam takes place. Right. So this is what the takes as a projection of lithography. So there is a micro contact printing technique where we have the feature size of 100 nanometers, and the disadvantage is high throughput is possible, cost is relatively low. Once an appropriate master has been fabricated, and one of the disadvantages, master can take many hourly even days, right? So these are some of the disadvantage of this particular micro contact printing technique. The feature size is around 100 nanometers, that is accepted, and the advantages is high throughput is possible. Cost is relatively low once an appropriate master has been fabricated, and disadvantage, master can take many hours, even days. Fabrication can take many hours. Even it takes several days also to fabricate the nanostructure, to fabricate the patterning using this type of technique, that is micro contact printing technique. So if you see the self-assembly, so it is a block copolymer lithography, phase separation of copolymer into pattern, and the feature size is around 25 nanometers, right? And the disadvantage is ordering only in an area of micrometer range possible, difficult to scale up. So this is what the scaling of the materials, right? So this is what the fabrication by using different, the people use the silicon wafer, and then etching is being done, and chemicals by using some polymer lithography. So polymer is being etched. So that is what block copolymer lithography, phase separation of copolymer into pattern, feature size of 25 nanometers. Disadvantage is ordering only in area of micrometer range possible and difficult to scale up. So nanoparticle media, pattern media, it is carbon nanotube, patterns of size 2 nanometer possible. Aligning metallic and semiconducting nanotube over large area is difficult. Production of metallic and semiconducting nanotube separately not possible. Iron platinum nanoparticles. Self-assembly in feature size of 4 nanometers. Suffers from aggregation of particle during processing. Carbon nanotube patterns of size around 2 nanometers possible. Aligning metallic and semiconducting nanotube over large area is difficult. Production of metallic and semiconducting nanotube separately not possible. Iron platinum nanoparticle self-assembly in feature size of 4 nanometers. Suffered from aggregation of particles during processing. So if you use the lithographic techniques, just a comparison, if you see all these particular techniques what we are seeing, so the interference, extreme ultraviolet, X-ray, E-beam, focus ion beam, the equipment cost in $1 million, interference is 1 million, extreme UV is 10, X-ray, E-beam is 3, focus ion beam is 3, and X-ray equipment cost is missing, and we will see that. And we have feature size, that is interference around 75 nanometers. Feature size, the resolution is 75 nanometers. Extreme ultraviolet is around 30 nanometers, and X-ray beam is around 80 nanometers. E-beam is around 75, and focus beam is around 50. And throughout pictures are 10 power 10, 10 power 11, 10 power 4, and 10 power 1 to 2. So energy utilized, energy joules per centimeter square can be up to 4. Extreme ultraviolet 40, it is around 16, 22, and requires a synchrotron. X-ray requires a synchrotron, right? So this is what the lithography technique, a comparison, and we have the E-beam E-beam projection around $10 million, and major feature size is 50, and throughput features are 10 power 10, energy joule per centimeter square 15, command large scale process, and focused ion beam projection 3, feature size nanometer 75, 10 power 10, 15, large scale process, and dip pen is around 0.2, 10 power 4, and not significant. Nano imprint depends upon master and not significant. So dip pen lithography to produce master, right? Cost of equipment is around 0.2 million. Tip speed is around 0.2 millimeters per second. Size of pattern is 14 to 20 nanometers. Spacing around 20 nanometers. Time to pattern is 1 centimeter square, that is equal to 6 days using 10 tips, right? So nano imprint lithography for replication, right? So this is what the SEM image. We have the SEM, and which having the diameter, micrometer dimension is 1 micrometer, and this is what the SEM image. This is what the AFM, and this is what the MFM. So AFM image gives the correct image when compared to MFM. MFM are used for magnetic samples, right? Magnetic force microscopy, where we have the silicon dioxide make master by E-beam lithography, form stamp by photopolymerization, form replica by photopolymerization, transfer pattern by reactive ion etching, right? Etching of it, etching of cobalt platinum materials, right? Evaporate magnetic thin film. So this is what nano imprint lithography for replication can be done. So the results of nano imprint lithography: area coating of 3 cm diameter possible, error is 5 or 3000 defective mesa, dimensions of mesa is diameter around 30 nanometers, height is 30 nanometers, spacing 8 nanometers, and bin density is 16 gigabyte per centimeter square. And the cost analysis assumptions: cost of production almost similar to transistor manufacture. Chip cost by atomic optical lithography around $145 per chip. One chip around 216 into transistors, and production is 24,000 chip per year. And cost of optical lithography is around 1.8 million, and imprint lithography is 0.1 million. And the cost by imprint lithography around $74.2 per chip. The area of the chip around 3 cm or approximately 7 cm square. And bit density is 16 giga per centimeter square, and cost to bit is $0.66 per gigabyte. So summary: so proposed process has potential to make inexpensive data storage. Proposed process is extension to current state. right? So from there, this material can be these are the references where we have taken this particular information. So this is what the references we have: BD terrace, Thomson nanofabricated in self-assembled magnetic structures or data storage devices. It's what taken Journal of Physics. D, Applied Physics, in the year 2005. From the journal, we have taken some information. And nanoscale imprinting, patterning of magnetic island by imprint lithography using feasible mold. So Applied Physics Letters, this is what in the journal published by well-known researchers in 2002. Right. Overall, if we see the differences, so these are the lithography techniques are just a comparison what we can bring out between the cost, equipment process, cost, equipment, feature size, throughout features, energy, joule per centi square, and what are the comments that can be obtained from this. Whereas in case of e-beam projection, we have a large scale process, whereas focused ion beam projection, we have a large scale process, and here it is not significant. So these are the important features what we need to understand. So when we speak about the tip pen lithography, the cost of equipment is around 0.2 million. So the tip speed where the tip frequently touches the surface, right? So the cantilever will enable this tip to frequently touch that particular patterning image, that particular substrate, right? To particular substrate. So the tip speed is around 0.2 millimeter per second, which is very nominal, right? So very high speed, right? That the size of patterning can be around 14 to 20 nanometer, and the spacing is around 20 nanometer. You can see the spacing here, right? So this is what the writing direction is. And nano patterning, and the time taken to pattern one pattern is around 6 days. So that's why this becomes one of the disadvantage of using this type of lithographies, right? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.